Hello everyone, welcome back to my channel, and today we are going to take the lecture 2 of the AWS series, which will take you from 0 to 1, which is completely designed for the beginners. So if you haven't watched the lecture 1, I would suggest you to go and learn about the cloud computing basics, which was discussed in the lecture 1, and it will help you to grasp the concept of the lecture 2 in a better way. So firstly, go and watch the lecture 1, and I will try to recall all the concepts that we have discussed in the lecture 1. And in today's lecture, we are going to take it forward, which we have discussed in the earlier lectures. And from the next lecture onwards, we will be starting the AWS Amazon Web Services, where I will be discussing the basic services, how Amazon Web Services evolved, and what are the basic services, and all that will be discussed in the upcoming lectures. So without further ado, let's get into lecture 2. And before moving forward, if you haven't subscribed to the channel, make sure to subscribe it, and don't forget to press the bell icon to get the latest update from the AWS series. So we are discussing the cloud computing with AWS, and today is the lecture 2. So what we have learned in lecture 1? So we have learned about the cloud computing. What is cloud computing? Why do we go for the cloud computing? Then we have discussed the history and origins of the cloud computing. Then we have discussed how did it evolve, how the cloud computing concept evolved. Then what are the characteristics of the cloud computing? Then we discussed the various characteristics in the detail, like the on-demand self-service, resource pooling, measured service, broad network access, rapid elasticity, and all that. We discussed the difference between the scalability and elasticity. Then we discussed the benefits of the cloud computing. Then we have discussed the types of cloud computing responsibilities, and the last topic was about the different types of cloud deployment model. So this lecture is just an extension of the lecture 1. So it is advisable to watch the lecture 1 first to get a better understanding of the lecture 2. So what we are going to learn in the today's lecture, that is lecture 2. So we are going to discuss about the total cost of ownership, that is TCO. Then we will discuss what is CapEx, what is Opex. Then we will see the difference between the CapEx and Opex. Then we will see the basic cloud architecture terminologies that are used in day-to-day terms, and you should be used to all this term, because we will be using it in a more frequent manner. Then we will discuss about the high availability, scalability, fault tolerance, high durability. These are the major cloud architecture terminologies that we will be using in our day-to-day discussion. Then we will discuss about the cloud service provider. What is cloud service provider? Then the landscape of the CSPs, how the landscape of the CSPs are getting involved nowadays, and what are the common cloud services, what is tier 1 services, what is tier 2, what is tier 3, and all those things will be covered in this lecture. So let's move ahead with the first topic, that is total cost of the ownership. So what is total cost of ownership? Suppose you are purchasing a car. So how do we calculate the cost involved in purchasing of the car? So first you will purchase a car. Then after purchasing of the car, all the maintenance will be up to you. You have to manage all the maintenance around it, and this also includes the cost of the insurance, the cost of the maintenance, regular maintenance, the cost of the regular service, and all that will be involved in the total cost of ownership. So that we call it TCO. How do we include this concept in the concept of the cloud? So let's discuss about the capital expenditure, that is CapEx, and the operational expenditure, that is Opex. So as you can see, we have an iceberg, and iceberg has two colors which represent the two behavior. That is, the iceberg with the light blue color is the cost which you are able to see, right, and the dark blue color represent the hidden cost which you are not able to see, but you are being charged for it. Like you have a credit card, and there are some hidden costs which gets added when the bill comes on on any day of the month. So there are some hidden costs which are there. So like this, even the capital expenditure, operation expenditure have the same concepts like the credit card concept goes. So we have capital expenditure. So where do we take this term in account? So we discussed this capital expenditure when we have everything on premise, like we have the servers, we have the compute, we have the storage, everything on premise. So we have to take care of all the maintenance, all the peoples, all the data center, all the IT stuff, everything we have to take care by ourselves, right? If I'm the owner, I have to take care of all the expenditure. So this is capital expenditure. Then I will talk about the operational expenditure. If I have deployed and moved all my particular organization towards the cloud, so I am just paying for the services which I am using for my particular organization, right? I am not paying any overhead cost or any hidden cost which is lying, which I am not able to see, right? So in capital expenditure, you are paying the software licensing fees. Why? Because you have your own company, you have set up your own networking, compute, storage, data centers, and everything on your expense, right? So you have to manage it. You have to purchase certain software. So it is based on the software licensing fees. And talking about the OPEX, so OPEX is based on the concept of the cloud. And in cloud, you are paying for what you use. So pay as per use. So what you use, you will pay just for it. So it is based on the subscription fee. You have to take a particular subscription, and either it is prepaid or postpaid. You have to pay for what you are using. So in CapEx, you are taking care of the implementation, configuration, training, right? And apart from that, you have to also take care of the physical security, hardware, IT personnel, maintenance, everything you have to take care by yourself. But in capital expenditure, you have to do the implementation by yourself, you have to do the configuration by yourself, you have to train the people by yourself, but you don't have to take care of the physical security, hardware maintenance, and the IT personnel who are operating that particular cloud services and all that. So all these expenditure are being covered under the cloud service provider, which you are taking for your use. Right. So this is the advantage of using the OPEX over the CapEx. So CapEx is used for the on-premise infrastructure. Suppose you have an organization, you have created your own servers, own compute, own data centers. So you are using the capital expenditure. And in contrast, if you are using the operational expenditure, you are particularly using the cloud services. And for that, you are using a subscription fee which you use. So if you talk about the AWS, you could save up to 69. According to a research, it has been found that you can save up to 69% a year by moving your infrastructure to the cloud. And if you use it for the 3 years, the total saving would be around $654,904. So it is very huge. It can make a very huge impact. Moving forward, what is exactly CapEx and Opex? I have given you a high level understanding of what is CapEx and Opex, and let's just start discussing about what is CapEx and Opex in a more detailed manner. So what is CapEx? So as per definition, is spending money upfront or on the physical infrastructure like the network or the hardware, computing system and all that, right? So deducting that expense from your tax bill over time. And for the OPEX, the cost associated with on-premises data center, that has been shifted the cost to the service provider. You have to only pay for the subscription fees and for the services which you are using from the cloud service provider, and the customer only has to be concerned with the non-physical cost, like taking the use of the network, taking the use of the VM instances like the virtual machine, containers. You have to only just pay for what you are using, what sort of computing resources you are using and all that. In CapEx, you are responsible for the server cost, storage cost, network cost, backend and archive cost, disaster recovery cost, then data centers cost. You have to rent it, you have to cool it, physical security, everything you have to take care by yourself. So there is a lot of things you have to take care when you are working on the on-premises. Then you have to also train the IT personnel for using that particular infrastructure. You have to train people for that too. So there's a huge amount of expenses which are involved in the on-premises, or in other words on the CapEx, right? So with capital expenses, you have to guess upfront what you plan to spend, right? So if on a particular day, if you are using a website which has 20 users, but you have built an infrastructure for users for 2000 users, so definitely it will cost you more. right? So you have to plan upfront what sort of services are needed, what sort of traffic will be coming to your website, and all that should be planned before time. But in the operational expenditure, you have some advantage over the capex. Why? Because you can use dynamic scaling. It is very elastic, as we have discussed in the earlier lecture, that it is very elastic. Elastic means dynamic scaling. It can scale up and down based on the traffic on a particular moment of time. So with operational expenses, you can try a product of the services without investing in the equipment. Obviously, you are just taking the services and not the physical infrastructure or the place where you can build your own server, data centers and all that. You don't have to rent a space or buy a space for that. Moving forward, talking about the basic cloud terminologies which we generally use in our day-to-day conversation when we talk about the cloud services. So the first one is the availability. So your availability to ensure service remains available, right? There is no downtime, or we can say it has very low latency, right? So it should be highly available, so HA. Then it should be very scalable. I have discussed it in the lecture 1. What is scalable? So scalable is when you are manually scaling up and down based on the requirement, based on the traffic that is coming to your application. So you can scale it up and down. So it is very flexible, we can say, right? So your ability to grow rapidly or unimpeded. Then talking about the elasticity. So elasticity is just dynamic scaling is known as elasticity. So your ability to shrink and grow to meet the demand. Then fault tolerance, whether your particular infrastructure is able to manage all those all the faults. Suppose on a particular moment of time on a data center where your data is stored, there is a bomb blast. So how can you recover your data? So there should be some sort of fault tolerance by which you can get your data back. So and the disaster recovery, which I was talking about just before with the bombing example, right? So the ability to recover from a failure, like crashing of the server. It rarely happens, but there is a probability for everything. Then it should be very highly durable to for the disaster recovery to happen. Then high availability. So let's discuss each one in greater detail. So what is high availability? So that means your ability for your service to remain available by ensuring that there is no single point of failure. Right, so there is no single point of failure, and even if there is a failure, you can just recover from it within 5 to 10 minutes and all that. Even then, it is a very huge loss, but it is in a minimal time, right? And ensure a certain level of performance. Talking about the AWS, there is elastic load balancing, and there are different types of the load balancer, like the network balancing and all that. So we will be discussing it in upcoming lectures of the AWS. So elastic load balancing is a service provided by the AWS which helps in transferring the load between the various virtual machines. Suppose you have users on a particular day, you have the 20 users, so you are just using the one VM, one virtual machine, or one instance of this of that machine. So don't worry about what is instance as of now, because I have not discussed it as so far. But in the upcoming lectures, I will be discussing about the containers, about the virtual machine. Everything will be discussed in detail. So stay with me, have patience. I will be teaching you everything from scratch. So we have users, and suppose I have 20 users, and on a particular day I just observe that I have 2000 users. So I have to suppose if I have a one server, and all the traffic was earlier coming to only one server, and the server was designed to be for the 20 users earlier, but all of a sudden 2000 users came to your server, so there will be load. So there is a one particular a service which are offered by the different cloud services, which is known as load balancer. What load balancer does? Load balancer basically divides your loads between the various instances of the machine which you have created. We call it VM1, VM2, VM3, right? So if VM1 we can consider it as a one server, VM2 as a different server, VM3 as a different server. So firstly, all the 2000 customers or the traffic was coming to your only one VM instance. Now with the help of the load balancer, or with the help of the service which is provided by the various cloud providers, and in this case elastic load balancer, your traffic is distributed among the 3 VM instances, right? We are taking an instance of the 3, so we are talking about the 3 VM instances, right? So elastic load balancing automatically distribute, it does elastic, dynamic scaling, so automatically distribute in incoming application traffic across multiple targets of virtual appliances. In this case, the virtual machine is one or more availability zones. We will discuss about what is region, what is availability zones, everything we will be discussing in the upcoming lectures. So running your workload across multiple availability zones ensure that even if the 1 or 2 availability zones becomes unavailable, application remain available, right? So if the load is distributed, so even if one of the instances is not working, so that load can be distributed among the other 2 instances. In this manner, there will be no downtime, and it will be very efficient to use, right? Now talking about the scalability, so ability to increase your capacity based on the increasing demand or the reducing demand is known as scalability, right? So talking about the AWS specific, Amazon auto scaling is a service provided by the AWS for scaling of your application, right? Amazon Web Services auto scaling is a service that assists organization in supervising the AWS services, managing and providing infrastructure upfront, right? And the services automatically adjust the capacity, maintaining steady, predictable maintenance performance at the lowest possible cost. Yes, so AWS or any cloud providers always ensures to provide you with the minimal billing cost, right? So there are some services which you can definitely use, which will help you to reduce the cost of the overall infrastructure which you are providing for your application, right? So there is a term known as horizontal or vertical scaling. So when we talk about the horizontal scaling, so increasing the performance, we can understand this by a following example. For horizontal scaling, imagine it like you can place different computers. We can place different computers on a line. Right, on a line, you can place different computers on a line. So horizontal scaling means you are purchasing new servers, right? So it means adding up new system, right? So we can consider it if I have one laptop earlier, if I was using one laptop earlier, due to the surge in the traffic, all of a sudden we are increasing it to 5. I have purchased 4 extra laptops, and I will consider it, I will call it a horizontal scaling. Now talking about the vertical scaling, in vertical scaling we are increasing the capacity of the server, right? We are not purchasing new infrastructure, we are just increasing the configuration of the existing system. Suppose I have this laptop and one business was operating from this laptop. In a certain day I have seen a surge in the traffic which was coming to my application. So instead of purchasing new computers, I am just scaling this particular scaling the configuration of my current PC which I am having. It is known as vertical scaling, and vertical scaling is more efficient as compared to the horizontal scaling, right? So in the upcoming lectures also we will discussing about the RDS service which is provided by the AWS, and all the services will be discussed in more detail. Now let's talk about elasticity. What is elasticity? So I have discussed this term a lot, and probably you are also aware of this term as of now. So elasticity is what do I mean by elasticity? It means dynamic scaling, right? So your ability to automatically increase or decrease your capacity based on the current demand of traffic, memory and computing power is known as elasticity. You can dynamically scale up and down based on the requirement. I should not intervene in the scaling up and down of the infrastructure provisioning, right? So you can provision giving or providing some instances for a particular application is known as provisioning, or removing some of the instances is known as decommissioning, right? So I have discussed what is horizontal scaling, what is vertical scaling. And in horizontal scaling, scaling out means adding more servers of the same size, right? Scaling out means adding more servers of the same size, and scaling in means removing more servers of the same size, right? This is a very simple to understand term. And vertical scaling is generally hard for traditional architecture, so you will usually only see horizontal scaling described with elasticity, right? So maybe I was wrong, I misspelled the earlier term. It was not vertical scaling, it was horizontal scaling, right? So vertical scaling is hard to achieve, you can always do the horizontal scaling, right? Fault tolerance, the ability of a system to continue operating even when one or more components fail, right? So even if, suppose I just discussed about a scenario where you have divided the number of traffic which was coming to your application into 3 VM instances, right? So your particular application or the cloud service should be able to recover from that fault. It can be the fault can be anything, the downtime or the crash of the servers or anything. It can be related to anything, right? So in a fault tolerant system, if one component failed, another component takes over its function without any disruption in service. Just like I have mentioned, your traffic were divided amongst the 3 instances. Even if on a certain scenario, if even the one instance stop working, the 2 instances are still alive, they can work, and you can transfer the load of the instance 1 to the instance 2 and 3. Right. In this way, there will be no downtime in your application, and in the real corporate world, this is how the application works. Right. Now, in AWS fault tolerance system, there are lots of services which are provided by the AWS for the fault tolerance. So it is auto scaling, elastic load balancing, elastic IPs, and reserved instances, elastic block store, and so many services are there. So this is the one RDS I was discussing earlier, relational database service. It is something we provide for. We will also discuss about why RDS is good for scaling. Right? Why do we use RDS when we talk about the scaling? It will be in the upcoming lectures. Don't feel overwhelmed as of now. I'm just just teaching about the basics of the cloud computing as of now. Why I'm teaching all this concept? Because these are the concepts which you should always be aware of when you are starting to learn about the cloud computing. Though I'm not teaching all the concepts, but these are the major concepts which you will be hearing from all the persons who are working in the cloud native landscape or working in the cloud services. Now the next one is high durability. What is high durability means? It means that your particular cloud service should be able to recover from the disaster or any cause of disaster in no time. Right. So your ability to recover from disaster and to prevent the loss of the data solution that recover from disaster is known as disaster recovery. Right. And it is a very important aspect of the cloud services. In the on-premises, it might be not possible, or even if it is possible, it may cost you a lot, because you have to spend a lot on building a good disaster recovery system and a fault tolerance system. Right. In the cloud services, you are saving a lot. Right. So by this time, you might have understood why we are moving towards the cloud services. Right. So when we talk about the higher durability, there are some of the questions which you have to think. Right. Go after this watching this lecture, go and search for this question. When we talk about the high durability, when we talk about the disaster recovery, you have to ask: do you have a backup when you are building an on-premises infrastructure? Do you have a backup? How fast can you restore that backup? Even if it is lost, how fast can you restore that backup? Does your backup still work after even getting your data back? Is it working? And the last question should be: how do you ensure current live data is not current? Even if you have the data in the current system now, you have successfully recovered your data. Is it working right now? So you have to consider all these things when you are building a high durability computing system. खत्म हो गया क्या ये? No, it's not it's not over as of now. We have to discuss some of the concepts even now. Moving towards what is cloud service provider, right? Who is cloud service provider? We have talked a lot about what is cloud computing, what is high availability, scalability, durability. Now let's talk about what is cloud service provider. What does cloud service provider do? Are all the services which you hear about, like the Linode, DigitalOcean, then Alibaba, IBM, are all the services cloud service provider? No. That is a clarification that I will be giving you in this lecture, right? So let's discuss about what is cloud service provider. So cloud service provider is a company which should fulfill this condition. If a particular service provider is fulfilling this condition, then you can call it a cloud service provider, or we can just consider it as a cloud platform. So there is a pretty good difference between the cloud platform and the cloud service provider. Not all cloud service provider are cloud platform, right? So a clear line of difference. So provides multiple cloud services, right? It provides multiple services, cloud services, like the tens to 100 of services, like the AWS has 200 plus major services, 1500 plus minor services and all that. And those cloud services can be chained together to create cloud architecture, like I am using the load balancer with the EC2 instance and all that. These are all the services which are provided by the AWS, and those cloud services are accessible via single unified API. Every cloud services and every service of the API, every service of the cloud can be accessed via an API that we can make or generate via the cloud service provider. And those cloud services utilize metered billing based on the usage per second or per hour, like the AWS work on the per hour. That means if we will charge only for that hour which you are using, suppose you have used it for the 1 hour, it will charge only for the 1 hour, but in the Azure you are charged for on a per second manner, right? So if you are using it for 1 minute, so you will charge only for the 60 second. So there's even a loss when you are using the AWS, we can say. Why? Because if you are using a service for the 26 minute in AWS, you have to even pay for the 60 minute or the 1 hour. Why? Because it is metered as per the hourly manner, right? Then these cloud services have rich monitoring. You should be always able to monitor how these services are performing in the backend. In the AWS specifically, AWS CloudTrail provide all these services. Then those cloud services have an infrastructure as a service offering. It should provide all the networking, computing, storage, database. Everything should be provided by that cloud service. Then we can call it a cloud service provider. And those cloud service offers automation via IAC, infrastructure as code. This is something we will discuss in more detail when we will learning about the DevOps. But DevOps is not something, or we can say it is beyond the scope of this lecture, so we will not be discussing that, right? So if a particular cloud service is offering all these services, even after lagging of 1 or 2, it's fine. But major services should be fulfilled, then we can call it as a cloud service provider. And if it is not fulfilling all these services or even 1 or 2, then we will call it a cloud platform, right? So let's discuss about the landscape of the CSP. So firstly, we have the tier 1, right? So top tier. So top tier are the companies, are the companies which have their own compute, own networking services, own databases, everything. They are fulfilling all the points which we have discussed in this slide, right? Though they are the top tier services, so we keep it in tier 1. Early to market, they are really early to market, right? Wide offering, strong synergies between services, well recognized in the industry, right? So these are the top 3 cloud services offered as being now. Then there comes the tier 2, or we call it the mid tier. So this is backed by the well-known companies, slow to innovate, right? Like we have heard of the IBM Cloud, but close to none of the folks have used the IBM Cloud who are watching this video right now, right? So, and Oracle Cloud, there is some offerings by the Oracle also, but these are the services which are owned by the well-known companies like the IBM, Oracle, but they are slow to innovate. So these are not much evolving. Then there come the tier 3 services. They have the virtual private server VPS that we have discussed in the lecture 1. So if you haven't watched the lecture 1, go and firstly watch the lecture 1 and turn to offer core IaaS offering, right? Earlier they were providing the VPS, virtual private server, but now they have some IaaS offerings like the networking, compute, storage, right? And we call it cloud platform and not the cloud providers, right? Because they are offering those services as of now, and they have only the IaaS, and which is the second last point. Those cloud services, they are only fulfilling the second last point, so they cannot be considered as a cloud service provider. Some of the well-known examples are the DigitalOcean, right? Vultr, then the Linode. These are all the services which comes in the tier 3. These are not the cloud service provider. So by the time, I hope that you are clear with what is cloud service provider and what is cloud platform. Cloud service provider our service can be called as a cloud service provider when it fulfills all these points, or even if 1 to 2 points are missing, right? And if a particular cloud which is only fulfilling 1 to 2 points, then it will not be considered in the cloud service provider, right? Moving towards landscape and the common cloud services. So common cloud services are cloud service provider that can have hundreds of cloud services that are being offered that are grouped into various type of services. Right now, let's discuss about the common cloud services. Right. So see, we have discussed a lot about what is cloud service, what is cloud deployment model, what is the major difference between the cloud service provider and the cloud platform and all that. Now we will discuss about, there are a lot of services which are available in the AWS, Azure, GCP, right? So they are broadly categorized into four different services. We call it the IaaS service, infrastructure as a service, right? And there is a bifurcation for all the services, like the compute. Under the compute there are lots of services. Under the database there are lots of services, right? So a cloud service provider can have hundreds of cloud services that are grouped into major types of services, right? So the four most common types of cloud services, the four core, we can say, infrastructure as a service, that would be compute. Compute is related to computation, right? So imagine having a virtual computer that can run multiple application, program and code. Then we have databases where you will be storing your data, right? Imagine a virtual database for storing, reporting, or database of a general purpose web application, right? Then we have networking. You want to access all these data from the cloud service provider, right? So this comes under the networking part. Then we have the storage part. So there is a difference between the storage and the databases. In the databases you can query, but in the storage you just want to store your data. So there is a major difference that we will be discussing when we will talk about the services that is attached with this databases and storage. Now, if you just want to learn more about all these services, I just regularly write blogs on the hash node. You can just go and watch all the blogs and read all the blogs related to the IaaS, PaaS, SaaS. I mostly write blogs around the APIs and the cloud native landscape. And if you haven't started writing blogs, I would suggest you to go and make your own account on the hash node and start writing blogs and share your learnings in public, because sharing your learnings in public is a good way to grow yourself, I always say, right? And this is all for this lecture 2, and from the lecture 3 onwards we will be discussing about the AWS services, and AWS services we will discuss about the basics of AWS, what is availability zones, what is what is the regions, and what are the major offerings of the AWS, and everything, how to make your own student free tier account, which is free for the 1 year, and we will be working with that only. So everything will be taught in the next lecture, so make sure you watch all this thing. And for the notes, everything will be in the caption, so make sure description, sorry, so everything will be in the description, so make sure to download all the notes, and see you in the next video. Till then, keep learning and happy coding.